All right, you guys. So on day 5, we are going to learn about the quadratic function in vertex form. So if you look right here, all right, there are 2 forms of a quadratic function, and both of these are on your formula chart. So the first form is standard form. This is the one we have been working in exclusively for like the past 3 weeks, right? Ax squared plus bx plus c. Okay, so we know basically everything we need to know about standard form of a quadratic. But what we're going to be talking about today is vertex form. And I'm hoping this looks really familiar. You'll notice the little emoji guy here saying, this looks just like transformation form. And it does, right? What we learned last week, or yesterday, I'm sorry, right? Let me just go back up here, right? So you'll notice when we have notice right here where it's got the number inside with the X. And then over here, it has numbers outside the parentheses hanging off on the end, right? That's exactly what we're doing when we write something in vertex form. So this is vertex form. You don't have to memorize it necessarily. It is on your formula chart, but hopefully you will memorize it as you do more and more problems. So here we go. Let's go talk about this weird vertex form. Now it's called vertex form because HK, let me write it over here. Notice the letters H and K. H and K is, let me write it a little neater here. HK is the vertex, right? Which is why it's called vertex form, because I can literally pull this number and this number out, and that's where the vertex is located. We don't have that ability with ax squared plus bx plus c. Like when it's in standard form, we've got to go graph it in Desmos and find the vertex and all that kind of stuff, right? But in vertex form, we can literally see the vertex right here, okay? Now, why does that work? Well, remember what we learned last class with transformation form, right? Remember, anytime you see a number inside the parentheses, that is a shift left or right, right? It's a horizontal movement because it's trapped inside with the X. And remember, it's always the opposite number of what you're seeing in the parentheses, right? So if it's like a -5, that means we're going right 5. But if it's a +5, that means we're going left 5, right? So just like we talked about last class, right? Then you have the plus K, right? And of course, that's a vertical shift, right? So this is the shift up or down, right? And what you see is what you get, right? If it's positive, you're going up. If it's negative, you're moving down, okay? And so I'm hoping, I'm going to scribble a whole bunch of stuff over here. You do not have to write all this in your notes, but I'm just sharing with you. So remember, the parent the parent quadratic function is y equals x squared. His vertex is at 0, 0, right? Well, here's the x squared right here, right? So if there's nothing around it, right, there's your x squared. So if his vertex is naturally at 0, 0, well, if this is telling me to shift left this many and up this many or whatever, right, then that's telling me where my new vertex is, right? Because all the points do that shift, right? So that's why the H and the K represent our vertex, right? Because it's just telling us how we are moving that parent quadratic function, right? Just like we talked about last class, okay? And then, of course, I don't want to forget to talk about the A, right? So remember, the A actually serves 2 purposes, right? If the A is positive, let me put the positive in front of the A. Gosh, I'm just not writing very neat. Okay, so if it's a positive A, right, then it opens up, right? So we know our parabola is opening up. And if it's a negative A, then it opens down, right? And we know this. It's the same thing with standard form, right? If it starts with a positive, it opens up. If it's a negative, it opens down. Same thing here, right? The cool thing about vertex and standard form is you'll notice the only variable they have in common is the A, right? Over here, I've got B's and C's, and over here I have H's and K's, and those are not at all the same numbers, but the A's are, which is why they use the same variable. So the A in standard form means the exact same thing as the A in vertex form. Okay, so it tells you whether the function opens up or down. It's also the vertical stretch or compression. Let me put, and, right, it's the vertical stretch or compression. And we, of course, had this discussion last class, but I'm just going to refresh your memory, right? It is a stretch if A is greater than 1. Oh, God, what is wrong with me today? If A is greater than 1, it's a stretch. And if A is a fraction between 0 and 1, then it is a compression. And we also don't want to forget that if you stretch it vertically, remember we had this conversation last class. Let me scroll back. Remember our little conversation with the hands, right? If you vertically stretch it, you're pulling it up and it has no choice but to get narrower, right? So if it's a stretch, it becomes a narrower parabola. But if you vertically compress it, you're pushing it down and it has no choice but to get wider when you're pushing it down, right? So those are big things to remember when you're talking about the A value. All right, so now that we understand these, what the A, the H, and the K stand for, we should be able to answer questions, kind of like what we did on the very first day of the unit, which we did with standard form. We're going to do the same thing with vertex form, okay? So here we go. And you can, of course, use Desmos still, right? You can type, as long as it says Y equals, you can totally type this into Desmos too and go look at what's happening, okay? All right, so here we go. Y equals 6x minus 5 squared minus 1. Okay, so the first question is, does this parabola open up or down? Well, it's definitely going to open up, and I know this because the A is, the whole function itself is positive, right? Because the A is positive. All right, where is the vertex? Well, the vertex comes from the HK, right? So it's the opposite of the number in the parentheses because this tells me that we went right 5. Remember, we learned this last class. Right, when I see a minus 5 in the parentheses, that means I went right 5, right? And when I see a minus 1, that means I went down 1. Well, then it makes perfect sense then if I start at the origin, because that's where my parent function's vertex is, right? If I start at the origin and I move right 5, that means I'm at the coordinate 5, and then I go down 1, so I'm at the coordinate 5, negative 1. Right? And so that is our vertex. All right, so I'm going to start sketching that over here. So 5, negative 1, 1, 2, 3, 4, 5, negative 1. So our vertex went from the origin to there. We know it opens up. I'm just going to draw a dashed line for right now, right? We know it opens up. Okay, I didn't mean to draw all those tiny dashes because I can't erase them all. There we go. Is it a max or min? Well, we know it opens up, so that means it's a minimum, right? Because that means this is the lowest point of our graph. What is the axis of symmetry? Well, of course, that has to be x equals 5. And remember, the axis of symmetry always comes from the x value of your vertex. The next question is so important, right? It says, is it narrower or wider than the parent function? Well, where do we go to see that? Well, we're going to go back to the A value, right? So remember, that's the A. That's definitely bigger than 1, right? So this guy is getting stretched 6 times his normal height, right? So he's definitely going to be narrower than the parent function, right? I'm going to come over here just for fun as a comparative here. Over 1, I'm going to kind of sketch my parent function. So let's just say this is my parent function. There we go. If that's my parent function, then I shifted it right 5 down 1. So my vertex, of course, is at 5, negative 1. And it's going to be much narrower, like a lot narrower, right? It's going to look like this. And again, we're just sketching. They don't have to be perfect graphs because there's not a grid here to work with, right? But the fact is, right, somebody is pulling and stretching this parabola so that it's 6 times taller, right? And so he's going to get narrower for sure. Okay, his domain and range. Well, of course, his domain is all real numbers. And his range, because he opens up, is y is greater than, and I know it's negative 1. Again, remember, your range always comes from the y value of your vertex. I'm going to draw a little arrow just to try to help you remember that in our notes there. Right? And remember, we know this because here is our wall that our function is hitting, right? So he's never allowed to dip lower than -1, and the entire graph exists above it. Okay, so again, essentially everything we did on day 1, we're just doing it from vertex form perspective, which is actually easier to graph, right? We don't have to actually have Desmos. I answered all those questions, and I didn't have to use Desmos once. All right, let me, there we go. I'm going to make sure I label that. All right, let's go to this one. I'm going to kind of do the same thing. I'm going to sketch a graph of my parent linear function. Why do I keep saying linear? I'm so sorry. Parent quadratic function. All right, so let's say this is y equals x squared. Remember, we do know his points technically, right? You can make an easy xy table like we've done all unit long. All right, so let's go look at this one. It says, does it open up or down? Well, I go to my a value for that, right? My a is negative, which means my whole function is negative, which means my new function opens down. And he opens down because he's a reflection over the x-axis, like we talked about last class. All right, so I'm trying to keep the same colors. Where's the vertex? Well, my vertex is the HK, right? Because remember, this +1 means we went left 1, right? And this +4 hanging off the end means we're going up 4. So if I start at the origin and I go left 1, up 4, well, then my new vertex is -1, 4, right? So I'm literally just pulling out that HK value. So -1, 4. So I'm going to go over here to my graph, -1, 4. Okay, so let's say that's here, right? Okay, and we know it opens down. So again, I'm going to I'm not sure how much wider or whatever. We'll get to that question in just one sec. All right, so we know it opens down. So that means our vertex is a maximum. It's the highest point on our downward facing parabola. All right, what is the axis of symmetry? Well, of course, that's x equals -1. Again, that's just the vertical line that passes through the vertex that cuts our parabola in half. Is it narrower or wider? Well, I don't know. Let me go look at the a value, right? So again, the a value is 1/2. It's not -1/2, right? It's just 1/2, right? The negative tells me it's a reflection, and then the 1/2 tells me someone is vertically compressing it to half its normal height. So if we are pushing it down, it has no choice but to be wider, right? Which means now I can go sketch a more accurate graph, right? I'm going to attempt to erase all these little dots. Okay, good enough. Right, so I know it's going to be wider than my parent function graph. Right, and again, we're just sketching, right? So we're just getting that idea. If you want to put it in Desmos to see how much wider, you're more than welcome to, right? But as long as I'm visibly graphing it or sketching it wider, that's really all I care about. All right, what is the domain and range? Obviously, the domain is all real numbers, and the range is y is everything less than or equal to 4. Again, that is where my wall is at, and I know that is 4 because that is the y value of my vertex. So all those little tips and tricks we learned in day 1 still apply. Okay. All right, so I'm hoping that makes sense. Being able to use vertex form to identify all those defining characteristics. All right, we're going to change it up a little bit, and we are going to write equations in vertex form, given the vertex and a point that passes through the parabola. All right, so basically, let me just underline it. So here we go. It has a vertex of 3, 6. All right, so if that's the vertex, then of course that means that is the h and k. All right, so h is 3 and k is 6. Now the other thing I know is that the parabola passes through the point 6, 5. Now when I graph a parabola, there's infinite points on the parabola. If I want to, I can make an XY table and I can put points in there. But what I want you to realize is anytime you're given a point, then that is a specific XY value that exists on the graph. Okay, and we're going to use that to our advantage to write the equation of this function. So really quick, let me go back. So notice what we have. We have an h and a k, and we have an x and a y. Okay, so I'm going to rewrite the vertex form here really quick. So remember, vertex form is y equals a x minus h squared plus k, right? That's vertex form. And look at everything we have, right? We were given the vertex, which is an hk. I'm going to underline those. And we were given a very specific x and y value that exists on this parabola. So what's the only variable left? Notice the a. So what we're going to do is we're going to use the x, the h, the y, and the k that they gave us, and we're going to solve for a. And it's the same steps over and over and over again, right? So once you get the hang of it, it's not that bad. It's just kind of weird at first. All right. I wanted a darker gray. There we go. So here we go. I'm going to start writing this function, this vertex form, but I'm going to plug in all the values that I know. So here we go. So instead of y, I'm going to plug in 5 equals a, because that's what I'm solving for. And then the x was 6 minus the h value of 3. And then I'm going to make sure I put my parentheses with my square. And then plus the k value of 6. And now I have an algebraic equation where I can solve for the value of a, because that's the one thing I'm missing. Now, this might seem kind of weird, but bear with me. So what we're going to do is we're going to simplify this. Remember, we have to do the order of operations here. So we're going to simplify the 6 minus 3 squared, which is a multiplier on the a. But it's very odd for us to put a multiplier behind a variable. So once I figure out what that number is, I'm going to put it in front of the a as a coefficient, because that's where multipliers should be placed. So here we go. I'm going to write 5 equals, okay, let's do the math right here. 6 minus 3 is 3. 3 squared is 9. But I'm going to put that 9 in front of the a instead of behind it, because a9 just looks weird. Okay. And then I'm going to bring down the plus 6. So once I've done that first step, you'll notice we just have a basic 2-step algebra equation to solve for a. So here we go. We're just going to subtract. We got to get the a by itself. So I'm going to subtract the 6 from both sides, which is going to give us -1 equals 9a. And then, of course, we need to get the a by itself. So we're going to divide by 9 on both sides. And that's going to give us a equals -1/9. Right? And I know that's not a super friendly number, but that's okay. Right? The a can be anything it wants to be. Now, we're not done, because all we've done is figured out what the a value was in our vertex form. So what we're going to do now is we're going to actually write the vertex form of this parabola. So the only thing I need to write vertex form is the a value, which is -1/9, the h, which was 3, and the k, which was 6. I do not need the x and the y anymore, because the x and y in the actual vertex form have to represent all the infinite x's and y's that exist on the parabola. So when I actually write my vertex form, it's going to be y equals, then I'm going to write my a, and then in parentheses, x minus h squared plus k. And that is the equation of our quadratic. Sorry, that box got weird. Now, the really cool thing about this is I can totally use Desmos to check this if I want to, right? And I'm going to do that for this very first one, just so you can kind of see how this works. All right, let's see if I can remember this function. So -1/9, let me go to Desmos. It's thinking about it. Okay, so if I type in -1, I'm try that again. 1/9, and then parentheses, x minus 3 squared. Was it plus 6? Oh my gosh, I need to go doubly check. Yeah, minus 3 plus 6. Okay, so here's our parabola. Let me go kind of shrink it down. Now I'm going to go ahead and check my vertex. Oh, look, my equation does have a vertex of 3, 6, which is exactly what they wanted. But I knew that was going to happen because that number is there. What I want to check is, does my graph in Desmos, does it pass through 6, 5? That's really what I want to check. So I'm going to go into Desmos, and here's the really cool thing about Desmos. I can actually type in the point 6, 5, and it's going to plot that point for me. You can even have it label it. And look, it's right there on my parabola. So of course my equation is correct because it has a vertex of 3, 6, and it is passing through the point 6, 5. So I am 100% sure that I have the correct vertex form of the quadratic in this case. Okay, super quick and easy. That took me like 5 seconds to type that in and check it. Okay, so totally worth it because that's a lot of steps. All right, let's try all of that again one more time. All right, so here we go. We're going to write the quadratic. I'm going to do the vertex. I'm going to write the vertex form down. Just again, as a reminder, ax minus h squared plus k. Okay, so here we go. They gave us the vertex, which is hk. And they gave us a point on the parabola, which is an x and a y. So they gave us the y, the x, the h, and the k. This is always, it's the same thing over and over again. So we're going to plug that in. Okay, so let's see. Our y value is negative 2.5 equals a. That's what we're solving for. Our x is 4. Our h was 3, so minus 3. And then it's going to be plus k, but my k is negative 2. So instead of writing plus negative 2, I forgot my square. Sorry. I'm just going to write minus 2. Okay. All right. So now remember, the whole point of this is we're going to clean this part up. And we're going to figure out what that number is and then move it to the front because we want our coefficients in front, not in the back. There we go. So if we do all this, 4 minus 3 is 1. 1 squared is 1. Okay, so this is going to just turn into a 1a, which of course you can just write a. You don't have to write the 1. I'm going to put that 1 there though so I don't lose anybody. Hold on, let me rewrite it. There we go. And now we need to solve for that a. Okay, well, it's already just an a almost by itself. The only thing we need to do is add the 2. So if I add 2, I'm going to get a equals, well, I've got negative 2.5 plus 2, which is going to give me negative 1/2 or negative 0.5. I don't care if you write it as a decimal or a fraction. Either one is fine. So this is our a value. And now that we know our a value, we can write our equation in vertex form, right? Which is going to be y equals the a we just found, so negative 1/2 or 0.5, and then x minus 3, x minus h squared plus k, but again, our k was negative 2. And yay, that should be our equation in vertex form that has that vertex and goes through that point. Okay, and again, I would spend the extra 5 seconds to go into Desmos, and I would type this in from line 1, and then I would go type in my XY coordinate into line 2, and see if that point does in fact lie on this parabola. Okay, all right. Wow, looks like we're going to do it 2 more times. Okay, I'm going to fly through these a little faster. All right, so it says write the equation that passes through the point. Okay, so be careful. This is the point, so this is the XY. And the vertex is the HK. All right. I'm going to write my vertex form down again. The more times you write the formula, the more it's going to be embedded into your brain a little better. All right, so here we go. Our y is 21. The a is what we're solving for. X is negative 3. Now notice h is negative 6. So you have to make sure you bring down the minus sign and the negative 6 because it's x minus h. So -3 minus -6, which is going to turn, it does give you a double negative, which obviously we should write that. I'm going to write that as one giant plus sign. Squared, and then my k is +3. There we go. So there is our math problem in which we're going to now solve for a. All right, we're going to simplify this. You can just put it in your calculator if you want to. Just do not forget to use parentheses. All right, if it's in parentheses on your paper, it must be in parentheses on your calculator. So again, -3 plus 6 is 3. 3 squared is 9. So that means I'm going to write this as 9a. Right, the multiplier goes in the front, not the back. And yay, we've got a two-step algebra equation to solve for a. So you know the steps, right? We're going to subtract the 3, right, which is going to give us 18 equals 9a. You can see where this is going, hopefully, right? Because we're going to divide by 9 on both sides. And that will give us a equals 2. Now, of course, that's not our answer, but that does give us the a value, which will allow us to then write our function y equals a, which 2, and then x plus 6, because it's the double negative, squared plus 3. And there we have it. So I know it kind of seemed awkward at first and like super time consuming and weird, right? But I'm hoping you can see it's right. We're just doing the same 3 steps over and over and over again, right? So once you kind of get that practice under your belt, right, it's not too bad. All right, if you want to, I would suggest pausing this video and trying to do this one yourself, and then unpause it and let it run and see if you did it correctly. That would be my suggestion. All right, I'm going to go ahead and let's see. So it's passing through the point 730, so that's the xy. Make sure you pay attention, right? The vertex is hk, and the point somewhere randomly on the parabola is your xy, so be careful. All right. Again, I'm going to write my vertex form so I don't forget what it is. There we go. All right, now we're going to plug in 30 for y. We're going to solve for that a value. 7 goes in for x. The h is negative, so it's going to create a double negative, which is going to make this 7 plus 1 squared. And then my k is also negative, so -2 hanging off the end. You got to be so careful with your signs, right? If you miss one little sign, right, it's going to throw the whole problem off. But again, checking it in decimals will allow you to figure that out. All right, so let's see. We're going to simplify that parentheses squared mess so we can figure out what the actual multiplier on the a is and just move it to the front. So 7 plus 1 is 8. 8 squared is 64. So it's a 64 multiplier on the a, and then I'm just going to bring everything down. All right, and once you get here, it's just a two-step algebra problem, right? We got to move everything away from the a, so we're going to add 2 to both sides, right? Which is going to give us 32 equals 64a. Now be very careful here, right? Keep in mind you're dividing by 64. You're not dividing by 32 because you're trying to get the a by itself, right? And so when we divide 32 by 64, that gives us 1/2. It does not give us 2, right? Because the bigger number is on the bottom. So we're just reducing the fraction. And yay, now we have our a value, which means now we can write the function. So this should give us y equals 1/2 x. Our h was -1, so it's going to be a +1 in the parentheses. And then our k is -2, so that's what's going to hang out on the side. Another cool little trick to do in your head just to help you out is to ask yourself, does this open up or down? Clearly it opens up. Is he wider or narrower than my parent function? Well, he has an a value of 1/2, which means somebody is pressing him down half to his normal height, so he's going to get wider, right? So all that stuff we talked about before, you can kind of think that through, and it just kind of helps reinforce everything that we're learning so far. Okay, we have one last thing to talk about, and then we're done. Now we're going to convert the other way, right? And we're going to convert from vertex form and we're going to rewrite it in standard form. It's a 4-step process. Again, it's one of those things that just takes a little bit of time, but once you get the hang of it, you should be okay. If you ever forget the steps, you can always come back to this page so you can reread the steps. The order of operations is imperative here, right? This is like basically a giant PEMDAS question. Okay, so here we go. It says, convert this lovely vertex form into standard form. Okay, so I'm going to kind of keep track of my steps on the side for this one and go pretty slow. And I'm going to check my answer in Desmos when I'm all done. All right, so step number 1, we're going to write the binomial twice because in PEMDAS, right, exponents always have to get done first. Please do not try to just square the 2 terms inside. You are not allowed to do that. You can only do that when you have factors inside the parentheses, not terms, right? So what you have to do is be like, I know x plus 5 squared means to write x plus 5 times itself, right? That is what squaring means. Right, and that is step number 1, is to write the binomial out twice. Okay, now I am going to bring everything else down. I'm going to do this one step at a time. Okay, so this is step 1, right? I'm going to go back here. Write the binomial out twice. All right, now what I have to do is multiply the binomials. We learned how to do that way back in Unit 6, right? So multiplying the binomials means you either need to do, you need to double distribute, right? We learned 2 different methods. You can either double distribute or use the box method. Okay. So I'm going to do this kind of off to the side. I think it might be easier for me if I go over here and multiply the x plus 5 times x plus 5. There is a pattern, of course, to this. So once you recognize it, you can start using that pattern. And some of you guys are probably getting to the point where you can actually do this in your head. Anyway, so x times x is x squared. X times 5 is 5x. Then I need to double distribute the positive 5. Which is going to give me another 5x, and then 5 times 5 is 25. You guys were really great at this in Unit 6, so I'm hoping we haven't forgotten this skill. And then don't forget your middle 2 terms are always going to be like terms, so we're going to add the 5x's together, which will give us 10 total x's. And that gives us x squared plus 10x plus 25. All right, so now what I'm going to do is I'm going to go to step number 2, right? Actually, I just did step number 2. Maybe I'll put that over here. Step number 2. That's what I just did right there. Let me relabel. This will be step 3. So now what I'm going to do is I'm going to write y equals -2. And in place of my 2 binomials, I'm going to replace that with x squared. I don't have enough room there. X squared plus 10x plus 25. And then don't forget that -3 hanging off the end. Notice we're starting to see that standard form, right? That's not our final answer, of course, because we can't have any parentheses, but it's getting there. All right, and then step 3 is to distribute the A. All right, so now that we've got rid of the double parentheses with the square, now we can distribute the -2 to everybody. So that's going to give us, oops, I'm going to keep it the blue here, y equals -2x squared minus 20x minus 50, and then I don't want to forget about that -3 dangling off the end still. Don't leave him off. And then step 4, we're going to combine like terms. And of course, the only like terms I actually have and will have will be that little dangling number, the k value that's dangling off on the side there. So my final answer is going to be negative 2x squared minus 20x minus 53. And notice I've gotten rid of all the parentheses. I've gotten rid of all the like terms. I've merged them all together. And so that is our final answer. Now let's talk about how to check this in Desmos. Well, guys, this parabola is the exact same as this parabola, or it should be. We've just written it in a different form. So when I type them both into Desmos, I should get the exact same graph. Okay, so here we go. Negative 2, 5, and negative 3. Here we go. Negative 2, 5 squared minus 3. Okay, hold on. I got to go see the other one. Negative 2, negative 20, negative 53. Negative 2, negative 20, x, negative 53. Oh my gosh, I hate it when Desmos does this. Sorry, I'll fix it in a minute. Notice if I toggle back and forth, oopsies, green, blue, green, or purple, green, purple, green, purple, green, purple. It's the exact same graph, right? So I can toggle between them and it's just going to change colors, but everything is identical, right? And that's how I know I did all of that algebra and simplifying that into standard form correctly. Okay, super easy to check. All right, again, you might want to pause and do this one by yourself and see if you can get the right answer. All right, so here we go. Oh, this one's a little trickier. It says, write the quadratic function with a vertex of negative 1, negative 2 that passes through 730 in standard form. Did we just do this one? 730, negative 1, negative 2. We did. Do you guys notice that that's the exact same question as number 4? 730, right? And negative 1, negative 2. All right, so we already did this question. I'm going to write C number 4 above, because I don't want to really do all that math again. C number 4 above, right? And the reason I'm saying that is because on number 4, we already found that in vertex form, right? We got y equals 1/2 x plus 1. I'm just going to write that down. Y equals negative, was it negative 1/2? Oh my gosh, my memory. Nope. Goodness. Positive 1/2. X plus 1 squared minus 2, I believe. Yeah. All right. So we already had found that vertex form up there in number 4. So if we hadn't, then you would have had to do all that work to get it into vertex form so that we could then convert it into standard form. Okay, but we've already done all the work, so no need to do that again. All right, so we're going to run through our 4 steps. So step number 1, expand the binomial and write it twice because it's getting squared. Step number 2. Now again, I'm going to go off to the side and do my binomial multiplication just so it doesn't get really messy and weird on top of my problem. So I'm going to double distribute. So that's going to give me x squared plus 1x. And again, you can use the box method if you prefer that. That's totally fine. And then this is going to give me plus 1x again, plus 1. And then you'll always have like terms in the middle here. So 1x plus 1x gives us 2x plus 1. All right, so that is what I'm going to replace. I'm going to write my 1/2. But this is going to give me x squared plus 2x plus 1. And then don't forget the minus 2, that k value hanging off the side. And we're getting so close, right? You can start seeing that standard form. But now we need to get rid of the 1/2 multiplier so we can get rid of that set of parentheses. So y equals 1/2 x squared. Half of 2 is 1, so that's just going to give me 1x. And then, of course, 1/2 times 1 gives me 1/2. Don't worry about that. It's no big deal. And then, of course, we have the minus 2 that we need to bring down. And then our last step is to just merge those two constants together. So 1/2 x squared plus x, and then a half minus 2 is negative 1.5, or negative 3/2 if you want to write it as a fraction. And that should be our answer. Now, you know me, I'm going to go to Desmos. Let me clean out my Desmos so really quick. Hold on. Desmos. I'm just going to take all this out. All right, so if I go, let's make sure my Desmos is back to normal. It is. Okay, yay. All right, so I'm going to type in my, I'm going to type in my original. So 1/2, 1, negative 2. All right, so 1/2, parentheses, x, oh my gosh, I already forgot what I just said, plus 1 minus 2. Sorry, y'all. Plus 1 squared minus 2. So there's my function, right? It's red, that lovely red parabola. Now I'm going to go see if what I just found in standard form gives me the same thing. So 1/2 x squared plus x minus 1.5. 1/2, 1, negative 1/2. 1/2 x squared plus 1x minus 1.5. Magic. Yay. Look at me toggling back and forth between identical parabolas, right? Vertex form, standard form, vertex form, standard form, right? But it's all the same. Yay, us. Right. All right, you guys, that is it for our day 5. I know that's a lot of algebra, right? We're having to do a lot of distributing, a lot of multiplying, right? Solving equations, right? So kind of everything we've learned all year long kind of coming all together, right? And using all those skills. Okay, so good luck with your homework. If you have any questions, of course, you can come in for tutorials and ask. All right, see you guys later.